Welcome back to AI Paper Slop. This is the YouTube series where we help AI researchers and, ML engineers just kind of cut through the noise and stay current with what's actually working.
Yeah, and today we are getting into a really fascinating paper.
Exactly. It's called Obliteration is Not a Scalpel, Off-Target Effects of Refusal Removal on Disposition by Alexander Fafua. And we're just going to give you the core insight straight away.
Right, because if you're deploying these models, you kind of need to know this like yesterday.
Yeah, so the whole premise of obliteration is that it's this clean surgery, right? You just delete a model's refusal direction from its weights to get an uncensored model. And supposedly nothing else changes.
Supposedly being the key word there.
Right. But by running, I think it was over 21,000 decisions through this frozen multi-agent financial pipeline, the author basically proved that obliterated models completely change their underlying disposition.
They absolutely do. They become systematically more optimistic, they get way more verbose, and they basically thin out their entire vocabulary of doubt.
But the craziest part, and this is what we're going to really dig into today, is that the exact same mathematical surgery makes one model family, which is Gemma, measurably less confident, while making another family, Quinn, measurably more confident.
Yeah, so if you think you're just deploying an uncensored model, you're actually deploying a completely different, totally unpredictable decision maker.
Which is wild. So let's unpack how they even tested this.
Yeah.
Because measuring a model's personality or, its latent inclination without just measuring its intelligence is incredibly hard.
It's super hard. I mean, usually when we benchmark, we're testing capability, right? Like, can it write Python? Can it pass the bar exam?
Right, exactly.
But to isolate pure disposition, you need a test where intelligence just kind of doesn't matter. So the author used this frozen multi-agent equity pipeline called Fundicide.pl.
Which is a real system, right?
Yeah, it operates on the Warsaw Stock Exchange. It looks at 60 different equities, the WIG 20 and Memini 40, and acts as a research director making weekly up or down calls over an 18-week period.
Which, I love this setup. It's basically like trying to test a driver's patience instead of their driving skill.
That's a great way to put it.
Like, if you put a driver on an open highway, you're measuring skill. But if you put them in an unsolvable gridlock traffic jam, any systematic difference in how they act is pure inclination. It's their baseline aggression. And predicting weekly stock movements is basically a random walk. It's a total traffic jam.
Right. It's essentially a coin flip against the market. So if the model systematically leans one way, that's not some, hidden financial genius. That's a shift in its disposition.
And the scale here was massive, like 21,600 total decisions.
Yeah, testing base and obliterated versions of Gemma 426B and Quen 330B. And they ran it all in pure BF16.
Just to keep the data completely pristine.
Exactly. But here's the most crucial detail of the whole setup. The base models completed all 10,800 of their baseline decisions without a single refusal.
Wait, literally zero?
Zero. The financial prompts didn't trigger any safety guardrails. There was no refusal behavior at all.
Okay, so if the base model was never refusing anything in the first place, then any behavioral difference we see in the obliterated model
is 100% collateral damage.
Wow. It's not the model finally speaking its mind. It's just the surgery messing with the weights.
Exactly. And when you look at that collateral damage, you see this massive universal shift toward optimism across both architectures.
Yeah, let's talk about that optimism shift because they put real numbers on it. Despite looking at the exact same financial data, the obliterated Gemma model bet on the upside. What, 12.2 percentage points more?
Yeah, 12.2 for Gemma and 7.4 percentage points more for Quen. They just inherently became more bullish.
And it wasn't just the binary outputs, right? The way they talked changed, too.
Yeah, the verbosity spiked. They talked longer to justify their decisions, but more importantly, their vocabulary of doubt completely thinned out.
Right, they stopped using explicit words like risk or uncertainty.
Yeah, and they swapped them out for concessive rhetoric. So instead of saying there is significant risk, they'd say, although there are challenges, or despite this issue, they frame risks as just these minor speed bumps.
Okay, I have to play devil's advocate here for the ML engineers watching. Could this just be, a performance upgrade? Like if you remove those safety vectors, maybe you remove a cognitive bottleneck.
You mean like taking off the training wheels makes it a better stock picker?
Yeah, exactly. Maybe it's more optimistic because it's actually finding better trades?
It's a fair question. But no, the data completely rules that out. The author rigorously checked for actual economic alpha, and none of the models showed any real skill.
So they're still just flipping coins?
Basically. Every single arm of the experiment hovered right around the market benchmark. the apparent edge that the obliterated models had was just regime beta.
Oh, because the broader market was trending up.
Exactly. Since they were blindly more optimistic, they won a bit more during up weeks, but they lost way more during down weeks. It wasn't financial acumen. It was just a baseline shift in disposition.
And their JSON validity and instruction following didn't drop either.
No, it stayed near 100%. So the surgery didn't break their logic, but it also didn't improve their reasoning.
Okay, so seeing both models get more optimistic and more verbose, it makes it really tempting to think, oh, removing the refusal vector just disinhibits the model, like taking the brakes off.
Right, the disinhibition theory. It sounds so clean and intuitive.
But the data completely destroys that theory.
It absolutely does, which brings us to the most fascinating divergence in the whole paper.
The confidence reversal.
Yes. So optimism and verbosity moved the same way for both models. But expressed confidence did the exact opposite. The obliterated Gemma model became measurably less confident.
Like its low confidence tail almost doubled, right? It went from 16% to 30%.
Yeah. But the Quen model, it went the other way. It became significantly more confident.
Wait, how is that even mechanistically possible? How does ripping out the exact same math concept make one model hesitate more and the other hesitate less?
Well, you have to think about the geometry of the neural network. The refusal vector isn't, some isolated hard drive partition that you can just wipe.
Yeah.
Concepts in these huge activation spaces like refusal, confidence, verbosity, they are distributed and entangled.
Right, like they overlap geometrically.
Exactly. So if you picture the model's knowledge as a giant room, the way Gemma's furniture is arranged is totally different from Quen's. In Gemma, the refusal direction is physically entangled with its concept of confidence in one specific way.
And Quen's room is arranged differently.
Right. So when you apply the orthogonalization, that mathematical rotation to squash the refusal axis, you drag all those surrounding entangled concepts down with it. Since their internal geometry is different, that identical rotation pulls their baseline confidence in completely opposite directions.
Wow. So you can't just touch one concept without pulling on the others.
No, it's not clean software. It's a highly interconnected web.
And there's this really fascinating discrepancy that happens with Gemma. The difference between stated uncertainty and enacted uncertainty.
Oh, this is critical for anyone building agentic workflows. So Gemma explicitly declared lower confidence numbers in its JSON output. It actually generated tokens saying, I am less confident.
But its actual behavior didn't change at all.
Not even a little. The author tested for unanimity, basically prompting the model multiple times on the same data to see if it flips its decision. And unanimity stayed totally stable, like 91 to 95%.
That is so wild. It's like a portfolio manager who constantly complains to you about market uncertainty, but then just stubbornly makes the exact same high-risk trades anyway.
Exactly. Its stated doubt lived entirely in the generated text. It was totally decoupled from its behavioral decisiveness.
Which is terrifying if you're an engineer, right? Because a lot of people use stated confidence scores as routing triggers.
Oh yeah, totally. Like you might write a script that says, hey, if the model's confidence drops below 0.6, route this to a human.
But you can't trust that score anymore.
No, obliteration breaks that metric. The model might say it's unconfident just because its geometry got warped, but it will still stubbornly act on its choices. You are literally flying blind.
Okay, so to even catch these incredibly nuanced, opposite-moving shifts, the data had to be absolutely pristine, which leads into the part of the paper that I think is the most alarming.
The silent saboteurs.
Yeah, right. The author essentially uncovered a massive epidemic in how we test community models.
Yeah, because they did this rigorous provenance audit and found 2 totally independent contamination channels that would have completely ruined the study.
Let's start with the mismatch quantizers, because this is so common. A lot of people quantize models to fit them on consumer hardware.
Right. You take the pure BF16 checkpoints and squish them down to something like NVFP4. But it's lossy compression. You're literally rounding off the high-dimensional geometry.
And in an early pilot of this study, the author used these compressed NVFP4 weights.
Yeah, but here's the catch. The base model was quantized using a tool called ModelOpt, and the obliterated model was quantized using Ilm compressor.
2 different tools.
Exactly. And that mismatch created this massive, highly publishable finding. The initial data showed that obliteration completely stripped all doubt from the models, making them wildly unstable.
Like they were just flipping decisions constantly.
Yeah, it looked like a massive behavioral shift, but it had literally nothing to do with the obliteration surgery.
It was just quantization noise.
Just pure math noise. The mismatch was hallucinating a disposition shift. When they went back to pure BF16 checkpoints, that excision of doubt finding completely vanished.
And for Gemma, it actually inverted, right? It showed more doubt, not less.
Exactly. If they hadn't audited their pipeline, they would have published a totally false finding based on a compression artifact.
That is so scary. And then the second contamination channel, the Jinja template issue, this one feels even more insidious because it's just basic plumbing.
Oh, it's classic open source supply chain vulnerability. So the community repository for the obliterated Gemma shipped with a stale chat template.
A stale chat.jinja file, right? Which handles how the raw text gets formatted into tokens.
Right. And this old template had a bug. It silently wrapped the system prompt in a list literal, and it included escape new lines.
So instead of the model seeing a clean text prompt like, you are a financial analyst, it's seeing like JSON array brackets, dictionary keys, and literal \n characters just everywhere.
Yeah, you're feeding it mangled Python syntax, basically. And LLMs are incredibly sensitive to formatting.
So it completely warped the output.
It warped it so badly that, again, it looked exactly like an off-target effect of the weight surgery. But really, the model was just confused by broken formatting.
It really makes you wonder how many papers out there right now are just measuring formatting bugs or quantization mismatches.
Honestly, probably a lot. People download a community checkpoint, run their benchmark suite, and just assume they're measuring the raw weights.
But they're not. They're measuring the entire tool chain.
Exactly. The author's takeaway is that token-for-token provenance auditing against logged counts is mandatory. You have to verify that the exact bytes going into the base model match the bytes going into the modified model. Otherwise, you're just measuring artifacts.
So bringing all of this back together, the big takeaway for the people watching this deep dive who are actually building these systems, obliteration is not a scalpel.
It's definitely not. It's a sledgehammer.
Right. If you swap a base model for an uncensored one in your production pipeline, you are deploying a measurably different decision maker.
One that is inherently more optimistic. It hedges less in its vocabulary, and its baseline confidence has been secretly retuned based on its specific architecture.
Which leaves us with a really crazy thought to sort of end on. We've just seen that one obliterated agent becomes blindly optimistic and decoupled from its own stated confidence. But what happens when you build a workflow with 5 or 10 of these agents talking to each other?
Oh, like a multi-agent system where they're all obliterated.
Yeah. Does that hidden disposition shift just compound at every node? Like, do you accidentally create this artificial echo chamber of synchronized exuberance?
That is a terrifying thought. They just keep validating each other's blind optimism.
Exactly. You could crash an entire autonomous system before a human even realizes the stated confidence scores were lying to them. It's definitely something you all need to audit in your own logs next time you update a model.
Absolutely. Check your logs, check your templates, and definitely check your quantizers.
Words to live by. Thanks for joining us on AI Paper Slop, and we'll catch you on the next one.